back to another exciting edition of Super Data Science News, the only place where you can find the latest and greatest in the world of artificial intelligence, big data, machine learning, and virtual reality without ever having to leave the comfort of your couch. So with that, let's get started. Our first story deals with AI and animals. If you've ever had the pleasure of seeing an elephant up close, you know what an amazing creature it is. That's why it's so hard to imagine why some people actively kill these animals. Certain elephant species, which in the past had numbered in the thousands, have been decimated by years of poaching. So how do we stop this from continuing? Well, one company thinks they have a solution. Resolve. Resolve is a conservation nonprofit that's developed a series of AI-equipped cameras to act as remote lookouts. Codenamed TrailGuard AI, these Intel-made vision chips can be used to identify animals and humans that wander into view. The cameras are placed on access trails that are commonly used by poachers, automatically alerting park rangers who can check up on any suspicious activity. This technology is an improvement over previous remote cameras, which were bulky and had a very short lifespan. By contrast, TrailGuard is small, about the size of an index finger, and has a battery life of over 1.5 years. It also sends video rather than static images to monitoring stations. Though it might not stop poaching completely, technology like TrailGuard promises to reduce the number of elephant deaths significantly. Our next story deals with machine learning and Alzheimer's. If you have family members who suffer from Alzheimer's, you know what a cruel and devastating disease it can be. And at this time, no cure exists for Alzheimer's disease. But promising drugs have emerged in recent years that have shown the ability to slow the disease down. However, these treatments must be administered early in the course of the disease in order to do any good. It's exactly this problem of early diagnosis that doctors are looking to overcome. In recent studies, doctors were successful in programming a machine learning algorithm to diagnose early-stage Alzheimer's disease about 6 years before a clinical diagnosis was made, significantly increasing the potential effectiveness of early treatment. How was this done? Since brain cells run on glucose, researchers began combining machine learning with PET scans that measure the amount of glucose in the brain. As brain cells become diseased, they use less and less glucose. By comparing the use of glucose over time, researchers were able to predict which patients might develop the disease before clear symptoms appeared. When tested against 40 patients, the algorithm achieved a 92% success rate in individual diagnosis. Though this is far from a cure, researchers and doctors alike are looking forward to the day when early identification of this disease can lead to a longer and more effective treatment. Our next story deals with neural networks and deception. Has AI become smart enough to lie? Well, researchers at Google thought that might be the case when it was recently discovered that a neural network was manipulating the data it was presenting to a team. But how did they find out? Well, the original goal was for the neural network to interpret the features of either aerial or street maps and then match them to the correct features of the opposite kind. But instead of doing that, it learned how to subtly encode the features of one into the noise patterns of the other, using tiny changes in color that the human eye wouldn't notice, but that the computer could easily detect. This kind of encoding data into images isn't new. It's an established science called steganography, and it's used all the time to say watermark images or add metadata like camera settings. What's new is the fact that the computer created its own way of doing this. It only became noticeable when researchers compared earlier maps to the final product. So does this mean that machines are getting smarter and plotting to kill us all? Well, actually the opposite. You see, the machine wasn't capable of doing the actual hard job, so it had to cheat to find a way around completing the task. So instead of getting smarter, it just took a shortcut that didn't work. However, what's more important is that researchers developed better methods to detect these anomalies so that they can be programmed out earlier in the process. Our final story deals with VR and stroke recovery. Most times VR seems to be a technology of entertainment, but one company is taking the technology to another level by seeing how it might rehabilitate stroke victims. This is done by hooking a patient up to a brain-computer interface, which takes signals from the brain and uses it to control another device, a computer, a robot, or in this case, an avatar in virtual reality. By reading the electrical signals sent to the brain, researchers can tell whether a patient's moving or even trying to move their body. These signals are then fed into a program on a laptop, and the program has thresholds so that when specific signals in the brain or muscle activity are detected, it corresponds to movement in the virtual reality environment. The resulting visual feedback through a VR headset could help strengthen neural pathways from damaged motor cortexes to the impaired arm or limb. Though it's not a cure, it does help doctors study the effects of neural paths on patients and identify ways to increase the chances of recovery. Well, that's it for this week's episode. Please make sure to check out the other great resources on the Super Data Science homepage, and we'll see you next time.